Hybrid search is a retrieval method that combines two different ways of finding relevant text: keyword matching and vector similarity. In this video, we'll cover three things: why keyword search alone breaks, why vector search alone also breaks, and how combining the two give you the best of both worlds. Welcome to Scovia Labs, where we turn AI ideas into everyday intuition. Let's quickly recap how RAG works. You have a big pile of documents. A user asks a question. The system needs to find the few chunks of text that are actually relevant and hand those to the LLM as context. That finding the relevant chunks step is retrieval. And retrieval is the foundation of the whole system. If you retrieve the wrong chunks, the LLM is working with the wrong information. No amount of clever prompting fixes that. So the question is, how do you search through thousands or millions of chunks and find the right ones? There are two classic approaches: keyword search and vector search. And it turns out neither one is enough by itself. Let's start with the old school approach: keyword search. This is the search method that's been around for decades. You can think about it as matching exact words, like Control F, on a huge scale. The classic algorithm here is called BM25, and it works by scoring documents based on how often and how rarely a query term appears. Keyword search is fast, predictable, and great at exact matches. If someone searches for error code 503, keyword search nails it. The exact phrase is either in the document or it isn't. But here's where it breaks. Suppose a user asks, "Why does my app keep crashing when I'm offline?" The right document might say, "The client throws an exception during network unavailability." Not a single shared word, but it's the same idea. It just uses a completely different vocabulary. Keyword search has no concept of meaning, it only knows tokens. So if the user's words don't appear in the document, keyword search comes up empty, even if the answer is sitting right there. This is the issue that modern vector search attempts to solve. Watch our video on why embeddings improve search for a detailed explanation of how vector search works. Vector search converts text into a list of numbers, which is a vector that captures the meaning rather than the exact wording. Similar ideas end up closer together in this numerical space, even if they use completely different words. This is why vector search can match app crashing offline with exception during network unavailability. They land near each other in the meaning space, even if there are zero overlapping words. That solves the keyword problem. So why not just use vector search for everything, right? Turns out vector search has its own blind spot. Embeddings are great at capturing general meaning, but they're often weak at exact rare tokens. Things like error codes, model numbers, legal clause references, or someone's exact name. If a user searches for error code 503, a vector search might return documents that are thematically about errors and servers, but miss the one document that literally contains 503. Because to the embedding model, 503 doesn't carry much semantic weight on its own. So vector search trades one failure mode for another. It's fuzzy where you sometimes need it to be exact. This is exactly the gap that hybrid search closes. The idea is simple: run both searches and then combine the results. Let's walk through it with one running example. Say a user asks, "What's the fix for error 503 when the service is offline?" Step 1 is running keyword search. It scores documents using something like BM25, which rewards documents containing rare specific terms like 503. Because 503 is a rare token across the whole corpus, any document containing it gets a strong score. This step is good at catching the literal needle in the haystack. Step 2 is where vector search runs in parallel. The query gets embedded into a vector. The system compares it against the embedded chunks and finds the ones that are close in meaning, like offline, unavailable, connection dropped, even if they never say 503. This step is good at catching the conceptual match. Now, step 3 is to combine the two ranked lists into one. So, how exactly should these be combined is the problem that needs explanation. This is the actual engineering problem. You now have two different scoring systems, BM25 scores and cosine similarity scores, and they're not on the same scale. A BM25 score of 12 and a cosine similarity of 0.81 don't mean the same thing. So you can't just add them together. The most common fix is a method called Reciprocal Rank Fusion, or RRF. Instead of combining the raw scores, RRF looks at the rank, which is the position of each document in each list. A document that's number 1 in keyword search and number 3 in vector search gets a combined score based on those rankings, and not the raw numbers. The formula for a single list looks like this, where rank is the document's position in that list and k is a small constant that softens the impact of being ranked 1 versus 2. You compute that score for each document in each list, and then you sum across the lists. Documents that show up high in both lists rise to the top. Documents that only show up in one list still get a fair shot, just a smaller one. This combination works because keyword search is precise but rigid, whereas vector search is flexible but fuzzy. Put them side by side and their weaknesses don't overlap. Wherever keyword search fails, like paraphrased questions, synonyms, different phrasing, and things like that, vector search picks up the slack. And where vector search fails, like exact codes, names, rare technical terms, etc., keyword search picks up the slack. That's the whole idea behind hybrid search. Two imperfect systems covering each other's blind spots. And this isn't just a theoretical nicety. In production RAG systems, this is often the difference between a chatbot that occasionally feels broken and the one that consistently finds the right chunk. It's worth understanding the limitations of hybrid search. Hybrid search is not strictly a superior version of either of these methods. It's a combination that trades a bit of complexity for more reliable coverage. It also doesn't fix bad chunking, bad embeddings, or a missing document. If the right information was never indexed in the first place, no fusion method can bring it back. And it's not free, right? Like now you're running two retrieval systems and a fusion step on every query, which adds latency and infrastructure cost compared to picking just one. So hybrid search is a deliberate trade-off. More retrieval coverage in exchange for more moving parts. So here's the core idea. Keyword search and vector search fail in different complementary ways. One misses paraphrases and the other misses exact tokens. And hybrid search fuses their rankings so neither of the blind spot sinks your retrieval. That gives you a system that's precise on the things that need to be exact and flexible on the things that need to be understood. I hope this helped you understand why most serious RAG systems don't choose between like keywords or vectors, they use both. Please subscribe to Scovia Labs for more eye opening AI insights, and as always, stay curious.